We're moving on to chapter 1.6 today, and we're going to talk about absolute value inequalities. So previously, this school year, we learned about inequalities. We learned how to solve them, how to graph them. Last week, the last couple weeks, we learned about absolute value equations. So today we're going to talk about absolute value inequalities. So a lot of the rules that we've learned in the past few weeks all still apply. There's just a couple new things added. So remember, when you're solving inequalities, you have to flip the sign when you divide or multiply by a negative number. So if I'm underlining something, that means it's important and you need to write it down as well. When you're solving these, you can always pretend like the inequality symbol is an equal sign, just so you don't get it confused whenever you're trying to solve it. And then just like absolute value equations, there still has to be a case 1 and a case 2. So our original problem might look something like this, where its absolute value of a plus b is less than c. And then our cases, so case 1 is always going to look the same, just like it did when we were solving equations. In case 2, we're going to flip the inequality sign and change the sign of the terms on the right. So I made that note there. You need to make sure that you write that down. So case 1 is always the same. Case 2, the sign flips, the inequality sign flips, and then the sign of the terms on the right change. Okay, so steps for solving absolute value inequalities. So you're going to want to write these down, so you're going to have to pause this slide a little bit so that you can catch up. So first thing, you need to isolate the absolute value bars. So just like we did with the equations, if there's anything outside of the bars on the same side of the inequality, it needs to be moved over. Then you need to determine if the absolute value is even possible at all. So maybe it doesn't even need to be solved. You can just say that it's no solution right off the bat. And I'll show you some examples of what that would look like. Then after you've decided if you can solve it or not, then you're going to set up your two cases. Then you're going to solve each case. You need to graph your solution just like we did with inequalities, and then make sure that you have your final answers circled. Okay, so in this blue bubble here, if you have the absolute value is greater than a negative number, you can automatically, you don't need to solve it or anything, you can just state that the answer is all real numbers. Okay, and then the graph for all real numbers is a number line that's completely filled in. So that means any number in the entire world would make this statement true. So that's all real numbers. Then, if we scroll down a little bit, the stuff that's in circled in the black pen, so those are my no solutions. So if I have the absolute value is less than a negative number, or absolute value is less than or equal to a negative number, that's no solution. And the graph for no solution is just a number line with nothing on it. No highlighting, nothing. All right, and then over on the left here in red pen, we've got outlined when to do an open and closed circle and when to shade right and when to shade left. So you're going to want to write those down as well. This slide is very important. All right, next we need to actually solve. So we've got negative 3 times the absolute value of x plus 4 is less than 33. So the first step is to make sure the absolute value bars are by themselves on the left-hand side. So they're not. There's a negative 3 out front. So we've got to move that negative 3 over to the other side. A lot of times students are going to want to take that negative 3 and distribute it, but we cannot distribute into absolute value bars. It's not the same thing as a parenthesis. So we have to get rid of it a different way. Right now it's connected by multiplication. So you have to think the opposite of multiplication is what? Division. Okay, so I'm going to take and divide negative 3 on both sides. So on the left, I'm left with x plus 4, absolute value. Remember, when you divide by a negative sign, you have to flip the inequality sign. And 33 divided by negative 3 is negative 11. So now I've got absolute value greater than a negative number. So I feel like that might be something we talked about. So I'm going to go back to the last slide, and I'm going to scroll down here. And I remembered right. So remember, in this blue bubble here, I said absolute value greater than a negative number is all real numbers. So I'm going to go back to my example and I'm going to say all real numbers. And then remember the graph for this one is a number line that's all shaded in. Okay, so my statement, all real numbers, is part of my solution, and then my graph is the other part. Next example, I've got absolute value of x plus 5 over 3 minus 3 is greater than 6. So first step, remember, is to make sure the absolute value bars are by themselves. We've got that minus 3 there. That needs to be moved over. So it's being subtracted right now. The opposite of subtracting is adding. So I'm going to add 3 to both sides. Absolute value of x plus 5 over 3 greater than 6 plus 3 is 9. All right, there's nothing unique about how this is set up, so I know I'm going to need to solve both cases. So I'm going to go ahead and set those up. So case 1, it's going to look the same as the original. I'm just going to get rid of the absolute value bars. So x plus 5 over 3 is greater than 9. All right, case 2, the left-hand side doesn't change. It's going to stay x plus 5 over 3. Remember, I need to flip the inequality sign and change the number of change the sign of the number on the right. So it's going to become negative 9. All right, and now I need to solve. So I'm trying to get x by itself. Right now it's trapped up top of the fraction, so I need to get rid of that 3. So I'm going to multiply both sides. Those are going to cancel. I'm left with x plus 5 is greater than 9 times 3 is 27. And then I need to subtract 5 from both sides. X is greater than 27 minus 5 is 22. All right, same thing on case 2. I'm going to multiply by 3 on both sides. X plus 5 less than negative 9 times 3 is negative 27. All right, I'm going to subtract 5. X is less than negative 27 minus 5 is negative 32. Okay, so I've got my two solutions. My two cases are solved here. So now I just need to graph. So I'm going to draw a number line. Doesn't need to be fancy. I need to put the smallest number to the left. So that would be negative 32. And the bigger number to the right, which is 22. Okay, for negative 32, this is less than. It's not equal to, so that means I'm going to use an open circle. And this is less than, which means I need to shade left. Okay, for 22, it's just greater than, it's not equal to, so I'm going to do an open circle. And I'm going to shade to the right. So this here is the solution to that absolute value inequality. Your homework, and you're going to get plenty of practice with this, is going to be on Google Classroom.